Unit 1, Inequalities. This video is a brief introduction to inequalities. Inequalities are a topic you should have learned in 7th grade, so in this video we will quickly go over what words are associated with inequalities, how to graph them, and the rules for solving them. This video will follow along with the sheet, Inequalities, What Do We Remember? If you don't have this, check my website to see if it's there as a PDF to download. The word inequality means not equal to. So instead of using the equal sign, we have new symbols. We have less than, because the smaller side comes first, less than or equal to, because it's a less than symbol with an equals line below it, greater than or equal to, and greater than. Record these in your boxes and see if you can come up with some other words for each of these. For example, where would minimum go, or maximum, or at least, or at most, no more than, no less than? All of those are associated with different symbols here. Now let's graph each of these. This first one says x is less than 3. Some numbers that would fall into that category are all of the negatives, such as -2, that's less than 3, -1, that's less than 3, 0, 1, 2. If we think about the number 3 is not less than 3. So that means that we want everything leading up to 3, but not 3 itself. I numbered my number line, ensuring that all of the numbers are at equal intervals, and then I'm going to put what's called an open circle above 3. That means I don't include 3. Now remember, as a side note, if I were to graph just x equals 3, it would look like this, a circle at 3. However, I want everything below 3, or all the numbers less than 3. So I draw an arrow pointing to all of the numbers that are smaller than 3, and I have an open circle, not including the 3. The next example says x is less than or equal to 3. So I'm going to graph both my x equals 3, which is a closed circle above the 3, and all the numbers below it. Similarly, for x is greater than or equal to -5, I need to number my number line, ensuring that my numbers are going in the correct direction. Remember that as we move farther to the left, the numbers get more negative. So here I want to include the number -5, and I want all of the numbers that are greater than that as well. Numbers that are greater than or equal to -5 include all of the negatives that are closer to 0 than -5, such as -4, -2. It also includes 0 and all the positive numbers, so I know that I shaded in the correct direction. Imagine that this line is really lots of different points all the way along here, because all of these points are actually greater than or equal to -5. And finally, x is greater than -5 is an open circle above the -5 and all of the numbers greater than it. Part 3 says to explain in words the difference between a closed circle and an open circle when you graph inequalities. Be sure to mention which symbols are representative of each type of circle. So we look and we see that x is less than 3 was an open circle. We see it right here where the circle is physically open. Similarly, x is greater than -5 is an open circle. However, x is less than or equal to 3 was closed, and x is greater than or equal to -5 is closed. So in your own words, explain why that is. We touched about it briefly a few minutes ago, but I'd like you to explain it yourself. The final part of this video is about solving inequalities. Solving inequalities is very similar to solving equations, except we have one specific rule that makes all the difference in the world. To isolate the variable in any inequality, I use the same steps as solving equations, except that when I multiply or divide by a negative number, I flip or reverse the inequality symbol. This means that my less than symbol becomes a greater than symbol, and vice versa, and my less than or equal to symbol becomes a greater than or equal to symbol whenever I multiply or divide on both sides, so when my inverse operation requires me to multiply or divide by a negative number. Let's look at these examples. The first one says 3x plus 4 is greater than -5. So I start by drawing the line and subtracting 4 from both sides, so I have 3x is greater than negative 9. Now I divide by 3 because my coefficient is a 3, so I have x is greater than negative 3. I do not flip the inequality symbol because the inverse operation that I performed was first subtracting 4 and then dividing by positive 3. So even though a negative was involved in my problem, I'm always looking to see what I did to both sides. In the next example, I have negative 2x plus 4 is less than 8. Right away I can see that I have a negative coefficient of x, and so at some point I'll have to divide by a negative. First, I'm going to subtract 4 from both sides, so I have negative 2x is less than 4. And now in order to isolate my x, I divide by negative 2. Right away, right here, I see that since I divided by a negative on both sides, I have to flip that symbol so it becomes a greater than. So I have x is greater than negative 2. If I had graphed x is less than negative 2, I'd be including a whole separate set of numbers as my solution. My last example here says 12 is less than negative x. Well, since I have a negative coefficient of x, that's really like a negative 1. So if I want to move this negative to the other side, I think of it like I'm dividing by negative 1 on both sides. So I have negative 12 is greater than, I flip the symbol, x. Now, I included a separate thing in this example also. I always want to put my variable first. So if negative 12 is greater than x, that means my negative 12 is actually bigger than my solutions. So x is less than negative 12. It's kind of like I flipped the whole thing around, but this is separate from flipping our symbol because we divided by a negative. Thanks for watching this video, and we'll be sure to answer any questions you have tomorrow. This was a quick recap so that when you come in, we can get started right away.